Okay, continue with the second part. Okay, so basic vectors and images. So basic vector and images. So we assume an m times an image. The general form of the transformation equation is as follows. Okay. So where TUV is the transformation, okay, K is the constant, okay, that is transform dependent. So this is a summation, which is M is the number of row, N is the number of column. So IRC is the input image. Okay, image means the spatial image, and the BRC colon UV. So this is the transformation. Okay, the inner product of the basis image and the transform in the spatial domain. Okay, so UV is the frequency domain variable, where U is the number of column, number of row, and V is the number of column. So TUV is the transform coefficient. So at the end, you will get a transform coefficient. Okay, and BRC, UV are the basis images. Okay, corresponding to each different value for U, V, and the size of each is RSC. Okay, so as been mentioned before, so there are a few technique of a few mathematic tools, okay, to be used to transform into a frequency domain. For example, the cosine CST, okay, the cosine transform, okay, the WHT, okay, Hadamard WHT, okay. So these different of tools, mathematic tools, the difference is only on the basis image. Okay, so the difference is on the basis image. So the process is the same, where you will inner product, okay, of the spatial domain with the basis image. So at the end, you will get a TUV, so the transform coefficient. So it can be visualized in this, okay, where you have the RC, okay, the 2 times 2 of the spatial, okay, and the 2 times 2 of the spatial, okay. So each of these 2 times 2, okay, will represent as the UV. Okay, UV is the frequency domain. So UV is 0, 1 and 0, 1. So we will go on an example later so that you will understand more. So the process of transforming the image data into another domain involves projecting the image onto the basis images. Projecting means you will do the inner product. Okay, so it depends on the basis image that you use. So if you use WHT, so the basis image will be different. So if you use sinus, okay, you will use different basis image. Okay, so the mathematical term of this projection process is called inner product. So inner product is where you will multiply the IRC. IRC is the spatial domain, the input image, with the basis image. So you project these two, then you will get TUV. So where A inner product means you will multiply the coefficient of A multiplied by E plus B multiplied by F, C multiplied by G plus D multiplied by H. Multiplied by H, then you will get this coefficient. Okay, so to find the transform coefficient, which is TUV, this is TUV, the frequency domain, we project the image IRC on the basis images. So this is the basis images. For example, T00, this is T00 is the projection of IRC and this basis image. So means that you will have 4 basis image, which is this is 0, 0, this is 0, 1, this is 1, 0, this is 1, 1. Okay, so you will inner product the IRC with the basis of 0, 0, which the output will be in T00. Then you will get the new another one, the projection of IRC and the basis image of 0, 1. This is the basis image of 0, 1. So you do the inner product between this IRC and basis 0, 1. Then you will get the coefficient of T0, 1. This is T0, 1. So next, we'll do the same, but you will inner product with this basis image, which is 1, 0. So the inner product of this basis image will be the coefficient of T10, and same goes to this one. So this coefficient tells us how similar the image is to the basis image. So the more alike they are, the bigger the coefficient. Okay, the coefficient is the projection of the IRC with the basis image. If the coefficient means the value, okay, the value that you get from the inner product. If it is bigger, then means that it is more alike to the basis image. If it is smaller, okay, then it will be more different, okay, with the basis image. So the transformation process composes the image into weighted sum. So weighted sum is the output of the inner product, okay, of basis image where T, U, V are the weight. So if you project the IRC with the basis of T0, 1, so you will get the weighted sum. So this weighted sum will be projected to the TUV. So then the output will be the weight, okay, of the TUV. So for example, this is the IRC. So this is the input image. So what you will do, you will project this input image with this basis image, which is the basis image of 0, 1. This is 0, 1. This is 0. This is 0, 0. This is 0, 1. So this is the 1, 0. And this is the basis of 1, 1. So what you will do, you will inner product 5 multiplied by 1, 5 multiplied by 1, plus 3 multiplied by 1, 3 multiplied by 1, plus 1 multiplied by 1, 1 multiplied by 1, plus 2 multiplied by 1, 2 multiplied by 1. So the weighted sum is 11. So the T0, 0 will be 1, 1. T00 is 11. So next, you project the IRC with this basis image, which you will get the T10. Means make 5 multiplied by 1, 3 multiplied by 1, This is 0, 0, 1, 0, 1. So this the best refer to 0, 1, 0. This is 1, 1. This is 0, 1. This is 0, 0. So to get T10, so you project this IRC with this basis image. To get this one, which is 0, 1, you project 5 with 1, 5 with 1, 3 multiplied by negative 1, 1 multiplied by 1, 2 multiplied by negative 1. Then you will get 1. And same goes to 5 and 3. So this is the projection of to get the TUV, where you will have the IRC and also the basis image. So the basis image will be different from one mathematical tools with another. So this is the concept of projecting a spatial domain to a frequency domain. So the one that we show, I show you on the image. So the basic process is like this. Okay, where you will project the IRC with the basis image, and at the end you will get the frequency domain, which is TUV. So to obtain the image from transform coefficient, we apply the inverse transform equation.